So far, we talked about the negation of universal and existential statements. Remember that the negation of a universal statement is equivalent to an existential statement. There is some x values in domain D such that the negation of qx and the negation of existential statement is going to be a universal statement. Now we talked about conditional statements. We say that, hey, P then Q is a universal statement. So how do we find the negation of the implication? Is the negation of P then Q is going to be just not P then not Q? Remember that in previous sections, we talked about the conversion of P then Q into, let me just erase this first. P then Q is converted to not P or Q. So first we need to do the conversion, right? When we are converting this into or, then we can easily find the negation. The negation of for any x in domain D, if px then qx is equivalent to there are some x values in domain D such that px and not qx. So remember that to find the negation of for any x in domain D, px then qx, we have to make the conversion first. It is the negation of for any x in domain D, not px or qx, right? Then, as we saw before, it's going to be equivalent to the negation of for all is going to be there exists some x in domain D such that the negation of px is going to be the double negation of px is going to be px or becomes and qx becomes not qx. Let's take a look at some examples and then we move on to contrapositive, converse, and inverse as well. Write a formal negation for the following statements. The very first statement says, for any people, for all people, like P, if P is blonde, then P has blue eyes, right? So first of all, let us convert this. It says, for any x in domain D, if Px, then Qx. Its negation, if you find the negation of this statement, it's a little bit here. As we saw before, is going to be there are some x in domain D such that, so pay attention everybody. This is the negation. Px and not Qx. So how do we write this down? We can say that, hey, there are some people like P such that P is blonde and P doesn't have blue eyes. Does not have blue eyes. Let's take a look at another example. Here you have, if the computer program has more than 100,000 lines, then it contains a bug. So this is your hypothesis here, right? This is your Px, and this is your Qx. Its negation, there are some computer programs such that Px, we're going to copy down the hypothesis. We are not changing the hypothesis. Those computer programs has more than 100,000 lines. Those have more than 100,000 lines and they don't contain bug. They don't contain bug. Next definition. Consider the statement, the universal statement, for every x in domain D, Px then Qx. As you remember, we can define the contrapositive. The contrapositive is still a universal statement. So take a look here. Here we defined implication for any x in domain D, if Px then Qx, the contrapositive, saying that, hey, for any x in domain D, if the negation of Qx, then you have the negation of Px. As you remember, we defined converse and also the inverse. All of those are universal statements. For the converse, as we defined it before, for any x in domain D, if Qx then Px, and for the inverse, for any x in domain D, if not Px, then not Qx. Nothing new. We saw this before, and we're going to, for example, take a look at one example to feel more comfortable about what's happening here. We just converted the contrapositive, converse, and inverse into a universal statement. If a real number is greater than 2, then its square is greater than 4. So first of all, let's write this guy down in its universal form. For any x in domain D, if Px, then Qx. So if we were to write down the contrapositive, it doesn't change the universal statement. The universal statement stays as the universal statement. For any x in domain D, if not Qx, then not Px. What's the meaning of that? If the square of x is not greater than 4, then the number is not greater than 2. So let me just specify the domain here. For any real number like x, if the square of the number is not greater than 4, then the number is not greater than 2. So this is the contrapositive. Now let us take a look at the converse. For the converse, as you can see, we're just switching the conclusion and hypothesis role. For any real number, if the square of the number is greater than 4, then the number is greater than 2. Now let us take a look at the inverse. For the inverse, it's the negation of hypothesis, then the negation of conclusion. For any real number, the negation of the hypothesis if the number is not greater than 2, then its square is not greater than 4.